VLSos here. This is a video lesson on the graph of sine. I have a circle plotted here. I'm going to focus on a point that is on the circle starting on the horizontal axis. And I'm going to imagine that this point travels along the edge of the circle, all the way around coming back to its original position. As it does, the point sweeps an angle whose side begins at the positive horizontal axis and whose other side is made with the center of the circle. So as the point travels along, this angle opens up and sweeps along and increases its measure until the angle comes to a full circle when the point returns to its starting position. We can call this angle theta. And what we're interested in is the height of the point, or the distance from the point to the horizontal axis. And we could ask, how is the height changing as the angle continues to increase? Those are the two variables that we want to compare. We want to compare the angle that is created as the point travels around. The angle starts at 0 when the point is on the horizontal axis. The angle increases to 90, then 180, then to 270, and completes the circle at 360 degrees. We want to compare that angle to the height of the point. When the point is on the bottom part of the circle, then the height is negative because it'll be the distance from the point to the horizontal axis. We want to compare those variables and graph them. The horizontal axis is the measure of the angle. The angle is going to start at 0, reach 90 degrees at the top of the circle, then 180 degrees when it reaches halfway around. At the bottom it's 270, and then a complete circle at 360 degrees. This pattern will repeat. The vertical axis is the height of the point. So at 90 degrees, the height reaches its maximum corresponding with the top of the circle here. And if we were working with a radius of 1, we could call this the unit circle, so the maximum height of the point would be 1. When the point travels to 180 degrees, the height is 0 because we've reached the horizontal axis, intersected the horizontal axis again. And at 270 degrees, the point reaches a minimum. If the radius of the circle is 1, that minimum is -1. And when the point travels to complete the circle at 360 degrees, we intersect the horizontal axis again with height of 0. So I've graphed these 5 points that were easy to find on the circle. But what about in between? How do I connect these points? Let's visualize the point beginning again. And as the point begins to travel along the circle, the height increases. At first, the height increases pretty rapidly, but as the point approaches its maximum, the increase in the height slows down. So we're not going to connect these 2 points with a straight line. We want to capture the idea that the height is increasing very quickly in the beginning and then slows down as it approaches its maximum with a curve that captures that kind of change. When the point passes the maximum, its height reduces or decreases slowly at first, and then the height reduces more quickly until it reaches the horizontal axis. We capture that with a curve that looks like this. As the angle increases, we have an increase in height that slows down until its minimum, and then afterwards is slow and the change in height speeds up. connecting these 2 points, we'll be done with a curve like this. And the point can continue to travel around and around. So this pattern that graphs the point's height is periodic. It repeats. And we can capture that idea in our graph with arrows that suggest that this curvature is repeating. The shape of this curve is called sinusoidal. And the function that calculates the height of a point given the angle is the sine function. So if the height is the same thing as the y-coordinate of the point that's traveling, then we find its height by putting the angle that's made into the sine function. This sinusoidal curve is a graph of sine.